purpose of this video is to explain to you how to compute reorder point in chapter 12. So first thing I want to do is draw your attention to the bottom right hand corner of this handout where I have placed in here the assumptions of the ROP model. So there are three basic ROP models, and they are that demand is variable and lead time is constant, or lead time is variable and demand is constant, or lead time and demand are both variable. These are the three basic reorder point models. They all rest on the notion of daily demand, which is little d, and they also will require the standard deviation of demand during the lead time, and in some cases require the standard deviation of lead time as well. So sometimes you'll see this annotation as well, which is the standard deviation of lead time. So with that, let's then turn our attentions to the fourth page of the handout. We see some terms that you need to make sure you have a handle on. So basically, how are ROP and EOQ related? Well, ROP is when to order, and EOQ is what to order, the amount, and this is when the stock drops. ROP is defined as the point at which stock should drop that would cause us to initiate an order. And sometimes we need to convert our annual demand over to a daily demand, in which case we would just take the annual demand and that formula right there. We may need to use the lead time, which I talked to you a little bit about before. And in this one, we're going to need to have our old friend the Z chart come back. And we're after creating what's called safety stock, which is just this notion of having a little bit of extra so we don't run out. Now, in this chapter, we have to use a one-tailed Z-test, which is different than what we did in chapter 6, where we needed a two-tailed Z-test. So here, if we were okay with a 50% stock out, then that would mean our Z value is equal to 0, because we'd be right in the center of our normal distribution. You would not likely see that. If we were okay with a 16% stock out, that would be like an 84% chance of them having the item in stock, which would be a Z value equal to 1, because we would be right there, which we would have our Z value equal to 1. 16% stock out means we're going to turn away 16% of the customers, but we're going to serve 84%. Then we've got the 10% stock out. There we're going to serve 90% of our customers. So our Z value will then be 1.29. And then if we're going to turn away 5%, so then we're going to be serving 95% of our customers, then we're going to have a Z value of 1.65. Now, if we want to serve 99% of our customers, now we're way out here on the tail, 2.3. So we're going to need these as we calculate our reorder point problem. So now let's turn the page and take a look at the first setup we've got. Here we have example 1. In example 1, demand is variable and lead time is constant. Remember, I told you there'd be 3 different ways we would do this. So in this one, we have demand is variable, lead time is constant. So therefore, we use this formula that is located right here. The reorder point will be calculated as daily demand times lead time times Z times the standard deviation of demand during the lead time, where the standard deviation of demand during the lead time is defined as this right here, standard deviation of demand times the square root of lead time. So every problem requires some calculation of this right here. It's just this varies. So when we have demand is variable and lead time is constant, this is the calculation that we use. Now, the next challenge always with these is to figure out which problem or which methodology we should be using, because I'm telling you in this one, and I tell you right up here, demand is variable and lead time is constant, but it can be difficult to know which one to use. And so I want to show you when you read this problem how you know which formula to use. So this says on average, the demand for iPhone 5s is 15 units per day with some variation. So right there, with some variation, we know demand equals variability. Because we got two clues, 15 units per day with some variation, as well as on average, the demand on average right here. That tells us it's not always exactly 15 units per day. So we have noted now also that D should be 15. So then we go on to note that the standard deviation of demand is 5. And the lead time, LT, is going to be 2. We would like a service level of 90%. So that means our Z ought to be 1.29. So we can go ahead and set up our calculation using this formula right here. So here we've got ROP, reorder point, will equal our daily demand 15 multiplied times our lead time of 2 plus our Z value, which we decided is 1.29, because that's to get us our 90% service level, where then we need to multiply by 5 times the square root of 2. And that's because this is our standard deviation of demand, and then this is our lead time. And in order to calculate the standard deviation of demand during lead time right here, we have to create this calculation. So we go ahead and do that, and we find out that the reorder point for this problem should be about 39.122. So what this means is when our stock drops to 39 units, it is time to initiate another order. So a reorder point of 39 tells us that when the stock drops to 39.122 units, we need to initiate another order. It doesn't tell us how much to order, it just tells us to initiate an order. Now, the next part here, number 3, tells you to do the same exact thing but using a 95% service level. So the only thing that will change will be to change your Z value. So you'll need to do this on your own here. Gives you a little practice to make sure you've got it. And once you finish this for homework, this problem here, 12.32, is a problem that is exactly the same as this example. So I strongly suggest working both of these things, pausing the video, working both of these things, and then coming back and doing the next type of problem. Now in this problem, example 2, the lead time is variable and the demand is constant. So for this problem, the formula changes slightly, but it's the same exact idea. So assume that the demand for the iPhone is 10 units per day, and the lead time is variable with an average of 6 days. So we know it's variable with an average of 6 days. Well, we know that means that the lead time is going to be variable and the demand is going to be constant. So we've got a lead time is about 6 days with a standard deviation of lead time of about 2 days. And then we have a daily demand of 10 units. So we've got the key information that we need to worry about. And then we can go about putting it right into the ROP formula. So for this problem, the ROP formula is similar to the other one, but slightly different because we've got variable lead time and constant demand. But still, ROP will equal our daily demand, which we know is 10, times our times our lead time, plus our Z value. I'm just going to leave it as Z, and we'll come back to that in a second. Our average daily demand, which is 10, multiplied by the standard deviation of lead time, which we know is 2. Now we've got to think about our Z value. So let's go back up here and note that our Z is related to this 5% stock out. So that means we want to serve 95% of the people in our service. So we're after that 95% service level, so therefore our Z value should be 1.65. So I put it here, and then I'm going to go ahead and take this out, this Z, and replace it then with 1.65. I didn't leave quite enough room there. So now we have everything we need to calculate our reorder point, the point at which our stock drops to that would cause us to say, oh, time to order. Now, one other thing I want to note here is this part of the equation right here, mark this in green, this is the safety stock. It's the little bit of extra that we have to have just in case something goes wrong. Now, we had this on the previous problem, but I was trying not to confuse you by throwing too many things at you at once. But always, everything past the plus sign is always the safety stock, or the little bit of extra that we need to hedge against stock outs and irregularities in demand and that sort of thing. Think about if we had perfectly steady demand and lead time, we could just initiate an order when our stock dropped to 20 and we would be fine. We would always have plenty. But because, life is not quite that predictable, we have to have something called safety stock, which is this notion of a little bit of extra to save us from running out if something, goes differently than we planned. So we end up then with 33 for safety stock and a total of 93. So this 93 you see noted right here, this number suggests that when our stock drops to 93, it's time to initiate an order. This number of 93 takes into account two things. One, the regular daily demand times the lead time. That's what the 60 is right here. That just accounts for if we had exactly steady demand of 10 units per day. We have a lead time of 6 days, so we need to order when our stock drops to 60 or else we'll run out because we're using up 10 each day. But it also accounts for this in case we have some irregularities. Since we have a lead time of 6 days with a standard deviation of 2, then we know that 68% of the time, just right off the bat, that time could vary between 4 and 8 days. So we need to have a little bit of extra there to meet demand on the chance that our stock arrives in a flexible time, or on the chance that our stock arrives in 8 days instead of what we think of as 6. Thus, our reorder point is 93 and our safety stock is 33. And of course, this 33 is a part of the 93. All right, with that, I think it would be a good idea to practice this on this next part here, this thinking beyond, where I'd like you to do basically the same problem, but just change the lead time from reduce it to 4 days. So it was 6, so it's down to 4 days with the standard deviation still of 2. And you should see the reorder point drop some. As well, this problem here in the textbook also is set up like this one with variable lead time and constant demand, and this would be a great chance to practice this same skill. Now we're going to move on to the final model in this track, and that is a reorder point model that incorporates variable lead time and demand. This model really lets us do it all. It incorporates both variable lead time and variable demand. Notice, once again, the only thing that really changes is this right here. It is just the standard deviation of demand during the lead time. And this time we calculate it with this formula here that is listed. It's a little bit blurry here. Where we take the average lead time, we multiply it by the standard deviation of demand squared plus the average demand squared times the standard deviation of lead time squared. So let's go ahead then and practice that right here. First thing we'll do is identify the key numbers in the computation, which are going to be daily demand, little d, which is the daily demand of 25 units, the lead time, which is so you'll notice I highlighted it, that I put the demand in blue here. So we've got the daily demand of 25 with the standard deviation of 5, and then I made both of those blue down here. And then we've got the lead time with its average is 10, and then the standard deviation of lead time being 2. Those are both in green, and I've got them highlighted here in green as well. And then the Z value set at 95% because we have a risk of stock out of 5%, which means we want to serve 95% of our customers, and that Z value then would be 1.65. So now we have the key information that we need to set up our equation here. So let's go ahead and move to setting that up. So now let's go ahead down here and just take a look at the equation. I've kind of set it up, but we'll go through it anyways. So we need daily demand times lead time. So our daily demand, is 25, and then our lead time is 10. So let's go ahead and put that. All right, so I went ahead and wrote it there, color coded. We've got 25 times 10, so that's going to be our daily demand of 25 iPhones, and we have 10 days in our lead time. So if everything went perfectly and we never had a delay in deliveries and our demand was never variable, then if we just ordered when our supply dropped down to 250, we would be fine. But because we know we have variable lead time and we have variable demand, we have to add this little bit of extra, which of course we know is our safety stock. So we're setting our stock out, our risk of stock out to 95%. So we have a 1.65 Z value. So I've put that in there right there. And then now we'll go ahead and put this stuff underneath the radical. So we need the average lead time, which we know is going to be 10. And we're going to multiply that by the average demand, the standard deviation of demand squared. And you'll note that the only number underneath this radical that is not squared is this number right here, this average lead time. So the standard deviation of demand squared, as you know, is 5. So that's going to be 5 squared, or 25, but we'll write it as 5 squared. And then we're going to close up our hard parentheses right here. And then we're going to add to that now the daily demand squared. So in our case, that's 25 squared. Plus, we need the standard deviation of the lead time squared. So since the standard deviation of the lead time is 2, we want to then put that in there and square it. And so since the standard deviation of the lead time is 4 days, we'll go ahead and put that in there and square it. So I've done that, and I've squared it, and I've closed off the hard parentheses. Now we'll go ahead and do our calculation, being careful to observe the order of operations rules. So I'm not going to bore you with those, but make sure you follow them in order to get the right number underneath the radical. And then I'll write it out here to the right. I'll calculate it, write it out here to the right, and then you can just check your numbers. So as you can see, I have worked it all the way out here, and we end up with 417, which means that when our stock drops to 417, we should place an order. It doesn't really explain how much we should order, but just that we should place an order when our stock drops to 417. Place an order when stock drops to 417. Okay? Now, the last thing I want to point out to you is here's a thinking beyond question that kind of goes with this. And you can see that a few things changed here, and that is I had to calculate the economic order quantity, which would be how much to order. And then I calculated out the reorder point for you given these new parameters. So you'll notice that the reorder point goes down a little bit, but I would like you to work this out and then kind of come back and look at what I have here and see if that agrees with you. Furthermore, I'd like you to do this problem here as homework, and we can talk about this stuff in class on Tuesday. All right, see you soon. Bye.